Hey everyone, welcome back. So today we're going to be solving Leetcode 3152, and this is actually problem of the day for today. So as you can see, I'm on a streak, and I'll try to maintain that streak. Okay, and whenever I find a solution, I'll post it so that you guys can also refer through it and then try doing it on your own. Okay. This is actually a sequel of another problem, and that is special array 1. So if you not solve that problem, I would suggest you to solve that problem before you do this. That is a very simple problem, but it gives you the foundation for this problem. Okay. So the problem states that you're given nums. This is an array of integers, and then you're given something called as queries. With it's a 2D array, and it has two elements. One is the start, and another one is the end. Okay. So you will have to find. So basically, a special array is something wherein the adjacent elements, the adjacent pair, okay, in a subarray or in array, where the parity of the elements is maintained. By parity, what I mean is, you have 3 and 4. So basically, it should be alternating, odd and even, even and odd. It should be alternating. If you're starting with odd, it should be odd, even, and if you're starting with even, odd, even, odd. Okay. So if you see over here, this if you take the entire array, this particular 3 is odd, and next is supposed to be even. Okay. 1 is odd, 2 is even, and 6, since it's even, it's supposed to be odd over here, but it's even. So this does not maintain the parity. So this particular subarray is what will give you. It's not a special array, but this array till here is a special array as it follows the parity rule. Okay. Problem is pretty simple. The question asked is pretty simple. So now the thing is, we'll have to figure out. So 0 to 4 is your index. So 0 and 4 are your index. So in this particular subarray, our task is to figure out if that particular subarray is a good subarray or not. Right. This is what we'll be doing. Okay. Now let me open it up. Okay, perfect. Let me take the first example. Uh, 3, 4, 1, 2, and 6, and my queries are 0, 4 is my query. Okay, and I'm gonna have 0, 1, 2, 3, 4. Okay, so now my idea is that between this index 0 to 4, I need to figure out if this particular subarray, this is a subarray, right? If you don't know what a subarray is it's a part of an array. It can be the entire array also. It can be one element also. It's a contiguous part of an array. It can be one element also, or like 2 elements, or 3 elements, or the entire array itself. That is what a subarray is, right? It cannot be 4 and 2. It cannot be just 4 and 2. That's not a subarray. It's a contiguous part of an array. So given an index 0 to 4, we need to figure out if that is a particular good subarray or not. Okay. In this case, they have mentioned the entire array. Let's take another query just for our sake. We'll give another query 0 to 3. Okay, 0 to 3, and then another one with 3 to 4. Okay. Now let's see. So 0 to 4, I need to check if this entire subarray is a if it's a good subarray or not, right? Special subarray or not. So can I say I can basically check all the pairs, right? Ideally, right? So if you see, if you look at it, it's 3 and 4. So if you think about it, see, if you have to maintain the parity, the sum of the pair should be odd, right? Because you have 1 even, 1 odd, and then when you add 1 even and 1 odd, you will end up getting an odd number. That's fairly simple. So that's exactly what we're gonna do, right? So what I'm gonna do is I'm gonna check first. I'm gonna check 3 and 4. 3 and 4 is odd, right? So which means that this is a good pair. Okay, this is a good pair. I'll mark it as true. What about 4 and 1? 4 and 1 is also a good pair, so I'll mark it as true. What about 1 and 2? 1 and 2 is also a good pair because the sum is odd. I'll mark it as true. Now what about 2 and 6? Is 2 and 6 a good pair? The sum is supposed to be odd. Here the sum is even, so I'll mark it as false. So visually this is how you would do it. Right. Now, can I apply the same thing? Can I say that, whenever I'm at an element, I will check the adjacent element and I'll make sure that the parity is maintained. If it's not maintained, I'm gonna say that it's not a good pair, right? So that would be your brute force, right? So think about it. Basically, what you would be doing is, for each value in the query, you'll be going through the going through each of the values. This would be I, right? Right. This would be I, and for this range, you'll start another this thing. This would be I, so you'll start another one where your j is starting from 0, which will go to 4. And under that, what you'll do, the same thing that I told you about. You'll check the adjacent elements and then you'll see if it has the parity or not. Okay, that would be your brute force approach. But we need to think about it. Can we apply brute force? Right. Brute force is something that would just be a normal approach, your first approach, right? But we need to think, can we apply it? So that is where you need to check your constraints. So let's look at our constraints. Okay, we have nums.length given to be 1 to 10 power 5, right? So your nums.length is 10 power 5, meaning this this length is 10 power 5. It can go to 10 power 5, and your queries.length also can go till 10 power 5. So let's think about it. Can you apply this? What would be the time complexity of brute force? Brute force, wouldn't the time complexity of brute force be O of n square? Why am I saying that? Because you're going through the query which can go up till 10 power 5. Okay, worst case it's going up till 10 power 5. Okay, and you also are iterating from 0 to 4, 0 to 3, 3 to 4. Ideally, you're iterating the entire array. What if the range is given to you? What if the range of the entire element is given to you? That is, like for example, it's given 0 to 4. What if it's 10 power 5 and it's given to you as 0 to 10 power 5? Ideally, you're iterating from 0 to 10 power 5 in the inner loop. So this would also give you a time complexity 10 power 5. What is 10 power 5 into 10 power 5? This will give you 10 power 10, which is nothing but n square. If you consider this to be n and n, this is n square. Can you apply n square? No, you can't, right? You're getting a time complexity of 10 power 10. Would your online editors be able to process such high number of iterations or instructions? No, it won't be able to. At max, it can handle, I think, 10 power 7 is your threshold, right? So you cannot apply that. So we need to think of a better approach. Okay, let's think of a better approach. See, can we say that if you can hold the bad index? By bad index, what I mean is the one which is causing the array not to be a special array. Okay, for example, if you see 2 over here, 2 or 1, either 2 or 1 is giving me is what is causing the issue in this whole array. Right, if I consider this entire array, if this 2 was different, my bad, this 2 and 6, right, these two are the index, either one of them is what is causing me the issue, right? Let's say that 6 was different. Okay, in that case, if it is an odd number, in that case I can say that the entire array is good, but because of 6, this particular array is what is causing me the issue. This particular index is what's causing me the issue for making it not a special array, right? So if I find a way to mark that, can I do that? If I find a way to mark that 6 is what is causing me the issue, and because of that particular subarray, whatever subarray that you form with 1, 2 and 6, or 2 and 6, or 2, 4, 1 and 2, 4, 1, 2 and 6 is going to give me an error because of this particular 6. Okay, can I mark that? Yes, you can. Okay, so ideally what are we trying to reduce? Ideally what are we trying to reduce? See, the reason it's n square is for each query we are computing the entire array. Okay, so what we're trying to reduce from n square to n is nothing but this computation. And how can we do that? Can I say that if I already pre-compute and keep it, if I already pre-compute, let's see what the pre-computation is. But if I say that if I already pre-compute this and I keep it, can I say that I can just go through the queries and just get the values from the pre-computation? I can say that, right? So I wouldn't need this loop. So my time complexity would reduce from n square to n. Okay, that is the idea that we're trying to do. Okay, and how are we going to pre-compute? Let's look into that. Okay, so what would I do is I will do it first, then I'll tell you what concept that is. Okay, so what would I do is I have an array, okay, of 3, 4, 1, 2 and 6. Okay, can I create another array of same length? Okay, I've created another array of same length. Okay, okay, now let's go one by one. Okay, let's look at 3. Let me index it also. Let's look at 3. Okay, now if you consider only 3, is 3 a good pair? Not a good pair, is 3 a special array? Because I've told you a subarray can range from 1 to n also, but it should be a contiguous part of an array. So 3 also can be a subarray. Is 3 a good subarray? Yes, it is, right? Because it's only 3, right? So what will I do is, see, this subarray that I've created, this array that I've created, as I told you, I will mark only the bad elements. Okay, only the bad elements I'll mark, which is causing me the subarray to not be a special array. Okay, is 3 a bad element? No, it's not. So I'll give it a 0. Okay, forget 0. I won't mark it. Okay, let's go to 4. Okay, at 4, how do I check if it is a bad element or not? How do I check it? I can compare the previous element with this, right? Because again, the pair, adjacent pair should have the parity. Okay, does this have the parity with this? Yes, it does. So now the job is at 4. Okay, I'm checking 4 if 4 has a parity with 3. Okay, 3 is a good subarray. So my the responsibility of making these two subarrays, or whatever combination that comes over these two subarrays, is with 4 now. Okay, so whatever value 4, it decides if that subarray is a good subarray or not. Okay, is 4 a good subarray? Yes, it is, because we maintain the parity. This is odd, this is even. Good. Now let's go over here. 1. Let's check 1 with 4. Is 4 and 1 a good subarray? Now the responsibility is at 1. Is it a good subarray? Yes, it is. This is even and odd. Perfect. Let's go here. 2 and 6. 2 and 1. Is it a good subarray? Yes, it is. It's a good subarray. Okay. Now let's go to 6 and 1, 2. Is it a good subarray? No, it's not. It's not a good subarray. So now can I say that when this is what is causing the issue, can I mark it? Let's say I'm going to mark it with 1. Count as 1. Okay, count as 1. Now, since everything else is a good this thing, I'll mark it as 0. Now, is this my final array that I need to compute with? Is this my final array? It's final. Is this final? No, it's not, right? See, this is only telling you that 6 is not good. What about the subarray that is formed with that? What about the subarray that is formed with all of them, like with 6 included? Right. So what do I need to do? I need to create a prefix sum of that. By that what I mean is, I'll take 0, it's a good summary, this value would be 0, this value would be 0, this value would be 0, and this value would be 1. Okay, for this scenario the same thing, but ideally this is not the case. Maybe we can look into another example where it's different. Okay, actually let's consider another example. 4316. Okay, if I consider this, if I create this thing, this is a good summary. 3 and 4 is what? 3 and 4 is it's a good summary, right? So it will take this thing and this will process at 0. What about 3 and 1? Now the pointer is at 1, I'm checking. Now the pointer is at 1, I'm checking 1 and 3. Is it a good summary? No, it's not. So what I'm going to do is I'm going to take 0, add it with 1, not this one, make the count incremental count 1, and then I'm going to add 1. Is 1 and 6 a good summary? Here I've added it with 0. Here was 0 anyways. Yeah, 1 and 6 a good summary. Odd and even. Yes, it's a good summary. So I'm going to add it with 0 because it's not causing the issue. Now this is what is my prefix sum. Why am I computing prefix sum? We'll look into the queries and understand. Okay. Now, if my query says that, let's come back to this example. My query is initially saying that from 0 to 4, I need to say if it's a good summary or not. So if you know prefix sum of R, right and left, you get it as prefix sum of right minus prefix sum of left minus 1. This is the this is how you calculate prefix sum from an array, from a prefix sum array. Right. Now 0 to 4, prefix of 4 comma 0 should be prefix of 4, and when L is 0, you would ideally not consider it because your first value is 0. If you're checking prefix sum of 0 to 4, ideally means that you're checking the entire sum from here to here. So you don't need the left value ideally, right? Because the entire sum from here to here would be over here only. Okay, so this would be prefix sum of 4. That is nothing but 1. Now, what did I mark the good summary as? Good summary I marked as, what did I mark for the good summaries in the given array? I marked it as 0. Now, can I say that if the output that I'm getting is 1, can I say that, okay, there is one particular bad element which is causing this summary to be bad? I can say that, right? So if can I say if my count is greater than equal to 1, I can say there is a bad element. Okay, so here I can return false. Right. Now let's look into another example, 0 to 3. 0, 1, 2, 3, 4, 0 to 3. 0, 1, 2, 3, 4. This is my prefix sum. Okay. 0 to 3 is again 3 and 0. That is nothing but 3. So can I say that a prefix sum of 3 comma 0 is nothing but prefix sum of 3. That is nothing but 0. Since it's less than or equal to 1, I can return true. Right. Next, let's look at 3 to 4. Okay. So I said that prefix of 3 to 4 would ideally be prefix of 4 minus prefix of 3 minus 1, which will be prefix of 4 minus prefix of 2. This was my this is what I said. Right. Now let's see. Prefix of 2. Okay. Now tell me something. Should I consider prefix of L minus 1 or prefix of L plus 1? No. Wait. This might be confusing. I may not write it like that. Okay. No, let me write it in a different way. Prefix of, okay, here I mentioned that it's prefix of right and left. Okay, now can I say that instead of right and left for this particular scenario, I'll make it L plus 1. Why? Why? Because, can I write it like this? Prefix of L plus 1 minus 1. Why? Because I want prefix of L, not prefix of L minus 1. Because see, this particular if this particular sub array is bad, means that the element before that is what, you know. See, so if I, for example, 2 and 6, right, I'm saying that 6 is a bad element. Why? Because the element before that is 2, which is causing, which is what is not giving the parity, because both of them are even. So that is the reason I marked it as 1. So if I'm calculating 3 to 4, okay, I need prefix of right minus prefix of left only, right? Left only, right? I wouldn't need prefix of left minus 1, right? Because I need to know at that particular index if the element is bad or not. That is the reason I've taken it as prefix of L. The reason I've taken it as L plus 1 is the formula, not the formula. Ideally, this is how you apply PrefixSum. You know, if you solve any PrefixSum, you would know. So it will be prefix of R minus prefix of L. 1 and 1 will get cancelled. Prefix of L. What will give me my answer? Now, prefix of 3, prefix of 4 minus prefix of 3. Prefix at 4 is 1, prefix at 3 is 0. This will return me 1. Since it's greater than or equal to 1, I'm going to return. Let's verify. Is this my answer? Is this my answer? Right. So 3 to 4 is what is given. 3 to 4 is this. Does this maintain parity? It does not, because both of the elements are even. Okay, now I got the right answer. So this is the approach to it, the optimized approach. So optimized approaches O of n using PrefixSum. Okay, perfect. So let me show you the code that I've written for this, and then let's just go through the code. Yeah, this is the code that I've written for this. I've taken in PrefixSum array, okay, and I've taken a final array, okay. I've taken position. I'll tell you what the position is later, but I'm initializing PrefixSum of 0, 0, because the first element, of course, will be a good element. Okay, what I'm checking is from 1 I'm iterating through nums.length, right? I'm iterating through nums.length. Here what I'm checking is, I'm checking if nums of I percentage 2 is equal to nums of I minus 1 percentage 2. Okay, nums of I percentage 2 is the element at the current index, and I'm checking with the element at the previous index. Ideally, you can check if it is odd, then which means that it's a good pair. If it's even, that means it's bad pair. But I'm checking if it's equal at the same time. Okay, if it's not a good pair is when it'll come here, because this value should not be equal, right? If you're doing percentage 2, for even it'll be 0, and let's say the I minus also 1 is also even, then this will also be 0. So this will be equal, which means that it's not a good pair. So I'll come here. What will I do here? I will just take that prefix value, and then I'll add it to 1. If not, I know that it's a good pair, I'll add 0 to it. Simple. Okay, then what am I doing? I'm iterating through queries, and your start will be your value of 0 and your end will be value of 1. And I'm doing PrefixSum of end minus PrefixSum of start greater than or equal to 1. The same thing that I told you over here, wherein you have where you're checking if the count is greater than or equal to 1. Okay, this is what we did, and this is what I'm doing in the code as well. Okay, and now it's greater than or equal to 1. My final position of array, if it's greater than 1, I'm assigning it to be false, and position is nothing but the index of the final array, right? I'm incrementing it every time. It's a post increment. Else final array of position plus plus is true, and I'm going to return the final array. Okay, let me submit this and show you, and Perfect. Right. Yeah. I hope you understood the solution, and I would suggest for you to go through the problem on your own and try finding the and try understanding the solution that we've just done. Thank you.